right. Good evening, everybody. Thank you for taking the time out of your day, especially late in the day, to come out here for this session. We appreciate your time, and hopefully we can give you a good session here and some good content to take away. My name is Scott Ward. I'm a Principal Solutions Architect at AWS. I work on our external security services product team. So this is a team that owns security services, Security Hub, Macie, Detective, Inspector, GuardDuty, the new AWS Security Lake service. I work with our customers to help them understand how our services work, help them understand how they can integrate our services into their environment, and I also work with the product engineering teams to work with them on what do customers need and what should the services or features do in order to allow our customers to be able to use them and meet their security goals. I'm joined here today with Mrinal Shah, who's the head of container security for Warner Brothers Discovery and HBO Max. Mrinal is going to join us a little bit later to tell the HBO Max story about what they're doing when it comes to containers and threat detection. To start off with, we're just going to start talking about what are the AWS services that exist to help you when it comes to threat detection and vulnerability management for your containers. Talk through what those services do and how you might use them. And then that'll back up what Mrinal talks about and how they're actually using them and the value they're getting out of these services. So to start with, let's just highlight some of the challenges that customers have been facing when it comes to containers and security. Scale is a big one. When you're running containers to back your applications or your microservices, there's generally a lot more containers running than you might have with traditional infrastructure components. And even when you go down to just the level of a single EC2 instance, there's many containers running on that instance. So being able to understand which container is the problem and where is that container running, and is that container actually the problem or not, can be a challenge. Containers are short-lived. Containers might run for a couple of minutes, maybe an hour. Being able to detect a threat for a short-lived container and actually be able to identify that in a quick amount of time is very challenging. Containers are just different than what you might see with traditional infrastructure. They have different configurations, and understanding what's a good configuration and what's a secure configuration is challenging. There are various repositories out there that offer up container images that you can use to run an application or build on top of to run your own applications, but really knowing where that container image came from and is that a trusted source or not, and is the software in there something you could actually feel comfortable running in your environment can be a challenge. There's a general lack of expertise out there. So we all know that the security industry as a whole is lacking personnel and bodies to hire. Container knowledge and insight and the ability to gain that knowledge can be a challenge. Network configurations don't always account for the presence of containers, and that lack of container awareness from a network perspective can result in a malicious container being able to reach out and compromise other containers or parts of your environment. And then just a general lack of visibility, the ability to understand what containers do I have, where are they running, how are they interacting with each other, can be a challenge as well. Traditional tools don't account for containers, and incorporating that level of visibility with things that are so short-lived and have such massive scale can be challenging. So when we talk to our customers, that often leads to discussions around, what are the best practices that I can be following when it comes to securing my container workloads on AWS. So I'm going to take some time and talk through some specific services and features that we have within AWS that are going to help with this part of the discussion. So to start off with, I'm going to focus on Amazon GuardDuty and its EKS Protection feature. So this feature launched about a year ago for GuardDuty. It's an extension of the existing GuardDuty service. And for a quick just overview of what GuardDuty does as a whole, GuardDuty is our threat detection service for AWS. It's one-click enablement. With a click of a button or a single API call, you can turn on GuardDuty. As soon as you turn on GuardDuty, it will immediately start consuming data from the log sources that it supports based on the features that you've enabled. Those log sources include CloudTrail, VPC flow logs, Route 53 DNS query logs, S3 data event logs, and now EKS audit logs. GuardDuty consumes that information, and then it's going to generate findings in a couple of different ways. One, it's going to use threat intelligence AWS's own internal threat intelligence based on what we see from the AWS and the Amazon platform. And then we also have threat intelligence coming from our third-party providers, CrowdStrike, and Proofpoint. We also generate findings based on anomaly detections that are backed by machine learning. So GuardDuty understands how does your environment run, what's considered normal, and then can generate findings when it sees unusual behavior or patterns that are not typically observed in your environment. These are all there to help you take action at the end of the day. GuardDuty generates findings with a high, medium, or low severity. You can go consume those in the GuardDuty console or consume them through Amazon EventBridge, which is our message bus service, Amazon Security Hub, or the GuardDuty APIs. So let's talk more on the Kubernetes side and why this is needed. So every Kubernetes cluster that you launch has a control plane API. And you typically interact with this through the kubectl CLI, but you can also interact with it through straight REST calls. And so this API is what the cluster uses, what the pods and containers in the cluster use to communicate within that cluster. And it's also the API you use to manage the configuration of the cluster, to understand how things are configured or to make configuration changes. So this is a very powerful API. You can do a lot with your cluster, but it's also really important to understand what's happening with this API to identify if there's any malicious activity happening. So that's where Kubernetes audit logs come in. So these are sequential control plane log files that help you with insight into who made a change in the cluster, what API calls did they make, what IP address did they come from, what were the parameters they passed, were they actually successful or not. I look at this as CloudTrail for your Kubernetes clusters. So GuardDuty consumes these audit logs out of your EKS cluster. GuardDuty consumes these automatically, just like all the other log sources. So whether you're running one EKS cluster or hundreds of clusters, GuardDuty will automatically consume those log files and start looking through them and generating findings. And we generate findings along three main areas: policy, malicious access, and suspicious behavior. Policy is going to be looking at things like granting anonymous access or changing the dashboard for the cluster so it's now public. Malicious access is going to be looking at interaction from a known threat actor, traffic coming from a Tor exit node where somebody might be trying to hide their true identity, or that anonymous access actually being able to successfully connect to your environment. And then the suspicious behavior aspect, looking for things that are not expected to actually happen in a Kubernetes environment or a container-based environment. So running executions in an actual Kubernetes pod, a container being launched with very privileged access, access that might even allow it to get to the root operating system of the EC2 instance that it's actually running on. So from that high level, we then generate findings in GuardDuty, and those are aligned along the findings types that you see at the bottom of the slide here. These are aligned to the MITRE ATT&CK framework. So when you get a finding, you can understand in what phase of that attack framework is this finding related to, and what the actor or the suspicious behavior might be related to. So this will help guide you in how you might respond or remediate that particular finding. When it comes to the findings themselves, on the right-hand side, that's a sample GuardDuty EKS finding. I don't expect you to read that. I'll just walk you through the details of what you're going to get. You're going to get a description of what that finding is and some remediation guidance. I'm going to talk about that guidance here in just a minute. You're going to get a severity. So based on the activity and what we believe the importance of that is, we're going to give you a high, medium, or low severity. We'll give you a first and last observed. So first is the first time we actually saw this behavior happening. And last observed is if we continue to see that behavior happening on this particular cluster, we're going to update that finding. So you'll get some sense of if the first update and the last update are different, this potentially could still be happening in your environment. We give you the resources impacted, so help you understand the EKS cluster, the workload within that cluster, and the user associated with that cluster where this activity might be related. And then understand the action. So this would be the actual API interaction that's happening. So what was the API call? What were the parameters? Was it successful or not? Were items that we'll be giving you in those findings. So when you get the actual finding, you want to respond to it, you want to remediate it. And with GuardDuty for EKS, we've published remediation guidance to help you figure out what you need to do with these findings. So the very top link is the GuardDuty public documents, and every finding that we generate will have a link to this public document that highlights that specific finding. So we'll help you understand, what does this finding mean? Why did we generate this particular finding? And also give you some guidance on how you might go remediating that in your Kubernetes cluster. Often we will point to the second link here, which is a EKS security best practices. So this is a public repository that AWS maintains around what are the best practices to actually maintain that cluster or change the configuration of your cluster to address a particular security item. And so things you might find in here, we might walk you through how to actually make that cluster endpoint public, or how to implement whitelisting so that you're minimizing the interactions with that endpoint. Rotating credentials for a user that maybe has been compromised, backing out changes, terminating containers, patching containers, things that would help you be able to remediate that. Guidance I would give you is, as you go through this process, if you do have to deal with findings and walk through the remediation, think about where you might automate the steps that you're doing in the future. If you find yourself going through the same steps again and again, that might be a chance to investigate, could we actually programmatically implement some of this? Even if it's not the ultimate remediation, automating some of the investigation to get you the information you need to answer the question of, is this a true threat and how am I going to respond to it? But also, if you are making changes to your Kubernetes clusters that you actually would now consider to be best practice and how you want all your clusters to be configured in the future, can you fold that back in before anything is deployed or any changes are made in the future to actually validate that a cluster configuration is aligning with your prescribed best practices? So validating that in a potential deployment pipeline or scanning it when it gets into a repository before it's deployed. Now, where could you use GuardDuty for EKS protection? In my opinion, it could be across all of your AWS accounts. I think there's great use cases in many different situations. For customers there are customers who will give every one of their engineers their own AWS account. It's a sandbox environment. It's where they're going to do some experimentation, do their initial development work. You could have GuardDuty turned on for that particular account, watching the EKS activity, just looking out for a heads up of where an engineer might be putting a cluster into a configuration state that might not be so desired, and allow you to maybe get in front of what they might be trying to actually move forward into production. We have lots of customers who also have deployment pipelines where they're going to build and deploy container images, and they'll often move those through various environments before they get into production. So you could actually have GuardDuty turned on in your development and your testing environment, looking at clusters that are being deployed or updated and watching the activity of those clusters while there may be some testing or validation going on to determine if there are any potential threats that are happening due to the way that cluster is being configured. And then also watching it when it's under steady state in production, looking for additional threats that would only be seen from a production workload. And then, because GuardDuty integrates with AWS organizations, you can have a single delegated administrator account that can have visibility around the findings from all your other GuardDuty accounts that are enabled. So in this example, I've got a security team account that's enabled for GuardDuty, and it has the ability to see all the findings from all these other accounts. It allows that centralized security team to be able to take action across any one of those accounts or be able to route the findings onto the individual application owners so they can go and resolve the issue, but still ensuring that central security team has the right level of visibility. So moving on, but staying with the EKS story, I'd like to talk about Detective and its support for Amazon EKS and what you can do with that functionality. So to start with, Detective is our threat hunting service. It automatically consumes log files just like GuardDuty. It extracts time series event and information about particular resources such as login attempts, API calls, and the resources that are involved in a particular log file. It consumes data from CloudTrail, VPC flow logs, GuardDuty findings, and EKS audit logs. It's then going to take that information and put it into a graphical database to help capture the relationships between all of these resources that are extracted from these log files. And then we're going to give you a visual representation of that information so you can go and ask questions and look at that time series information to understand, is this operating normally? What's its current baseline? Is this spike that I'm seeing expected or unexpected for this particular resource? What other interactions has this resource had with this particular IP address or this particular EC2 instance? Specific to EKS, it's all based on those EKS audit logs again. Those are automatically consumed when you have this feature turned on. You're going to get a unified view of your EKS cluster. So you're going to be able to see the cluster, you're going to be able to see the pods, you're going to be able to see the containers that are deployed on those pods, as well as the users that are assigned in that particular cluster. You're going to be able to do an investigation for your EKS clusters, either through coming in and just starting a straight search, searching on a particular cluster, a pod, a container, an IP address, or you could start from a GuardDuty finding. So you can start from GuardDuty and pivot to detective, or you can go into detective and find a particular GuardDuty finding to start your investigation. And then there are 2 new tabs that have been added to detective to help you with the Kubernetes investigation. Tabs are Kubernetes activity and Kubernetes API calls. So with detective, these were the current resources that were available pre-EKS. These are resources you could investigate, understand how they're configured and their interactions. And with EKS, we've given you these 4 extra ones: the EKS cluster, the pod, the image, and the Kubernetes subject or the user. And so you can investigate these just with these 4, or you can investigate interactions with the other resources that detective has. And I think the best way to show this to you is to actually walk you through a brief investigation in detective on an EKS cluster based on a GuardDuty finding, and kind of show you how you would go through identifying the root cause, identify how this happened, and understand what's the impact, how far has this spread in my particular environment. So I'm going to start off here. This is a screenshot from detective. This is based on a GuardDuty finding. So the first thing I can see here is I'm seeing some of the resources that are associated with this particular GuardDuty finding. And the first thing that pops out to me is you can see at the bottom there in the actor, there's an IP address. I can see that this particular IP address was used to grant anonymous access into the cluster using the EKS admin user. So right away, that seems out of the ordinary. That's an administrative user granting anonymous access. So I'm going to start an investigation. And so the first thing I'm going to do is I'm actually going to start and I'm going to look at that EKS admin user. And so I can bring up the profile for that particular user in detective. It's going to help me understand the cluster that it's associated with and some key information about that particular user. But then if I scroll down, this is where I'm going to start using those new tabs. And so in this particular example, I'm using the Kubernetes API calls tab, and I can actually see for that particular IP address that was in question here, the 192.168.30.135, take a look at the API calls that were actually made. And in this case, I can actually see there was a create API call to create a cluster role binding, which is creating that new anonymous user in the Kubernetes cluster. So at this point, there seems to be a compromise related to this particular administrative service account. So I'm going to want to investigate a little bit further to understand how this actually happened. So I'm going to next pivot to looking at the IP address in question to understand what is this IP address actually associated with. So I can go and choose that IP address, bring up its profile page, scroll down, and I can now actually go look at the Kubernetes activity. What is the activity of this IP address as it relates to my Kubernetes clusters? In this case, I can see that it's actually associated with a Kubernetes pod in my environment. Specifically, it's this Debian Reader pod. So we have a pod named Debian Reader assigned to this. We want to investigate this a little bit further now to understand what's up with this pod and why is this happening. So clicking on that pod will actually bring me to the profile page of that pod. So now I have the details about that pod and how it's configured. And the one thing that stands out here is the service account. It's been assigned to this default reader account. That's supposed to be a read-only account. But I have this pod making executions to actually grant anonymous access, which is not what I would expect from a read-only account. So This is a potential indicator of compromise. I've got some things happening that I'm not expecting to happen in this particular pod or my particular cluster. So what I'm going to do next, I'm going to investigate a little bit further. I'm going to scroll down, and I'm actually going to take a look at the API activity in that particular pod. I can go and look in at the activity for that particular IP address, and I can see that there are some list activities that stand out. And the first one is I can see that that pod is actually listing secrets. Now, on its own, that may not be, that might be okay, because it does need that particular reader role to be able to authenticate itself with the pod. There may be some secrets that it needs to be able to do its job. So I need to dig a little bit deeper. And so what I can do is I can actually put a filter in searching for the word secret to see if maybe there's some other items that would help me better understand the scope and what's actually happening here. And by doing that, I actually see that I now have a get call that's related to a secret too. And I can clearly see here that this reader pod was actually able to get the token for that EKS admin user, which then allowed it to be able to make the call to grant anonymous access. So I'm getting a pretty good sense here that something attached to that pod is the ultimate indicator of what's happened here. What we can do here is from the pod view, we also show you the containers that were deployed in that particular pod. And so in this example, I found that there's only one container that was deployed in the pod. It was this Debian pod, Debian container that was running in the pod. So this seems to be the suspicious source of this particular activity that I've identified. So what I want to do now is I want to see, what did this anonymous user actually do? Did they do anything? They were granted access, but have they actually been interacting with the environment? And so from the detective search functionality, I can actually bring up this particular user, bring up that user's profile page, and I can go and start taking a look at the API calls that that user might have made. And what I see here is I've actually got a couple of calls that stand out, the patch and the create calls. So the patch call, this anonymous user was actually able to call the Kubernetes patch API for a web app pod. And that allows it to actually deploy updates to a Kubernetes pod without actually having to redeploy the pod. And then the create option actually was able to successfully create a cron job inside of a container. So I understand that they're actually starting to do things in this environment that I'm not okay with, that I need to investigate further. So I need to understand what's the impact. How far have they actually gone? How far has this spread? So I want to go in and I want to investigate that patch call to that web app pod that they made. So I can actually go in and search for that particular pod, bring it up, and I can actually see that there are some containers here that are XMRig containers. These are containers that are used for crypto mining. So I now have a better understanding of what's actually happened in this environment and where I might need to go in and remove or remediate some particular items or start to build a plan on what I need to be able to do to address what this anonymous user's been doing. So overall, through that quick investigation, I've been able to actually identify that root cause, which was that Debian container that was creating the access and causing the unusual behavior. We can see how that scenario happened. We actually saw that the container was actually able to get the secret for an administrator account and actually create that anonymous user. And then we were able to start identifying that impact. We were able to see it created a cron job. We were able to see it deployed some extra containers that were actually used for crypto mining. And so we can start to figure out what our remediation plans are going to be based on this information. Now, what I just did was an investigation based on a single GuardDuty finding. Within Detective, we have a new feature that was recently launched called Finding Groups that helps you see activity that is related to similar findings against a common activity. And so what you see here is a screenshot of a finding group that is focused on findings that are doing along the MITRE attack framework discovery and impact actions. And if I scroll down in those finding groups, I see a lot of the same things I just showed you in that investigation, but I also see that there are two other GuardDuty findings that are related to this same group and type of activities. I can also see the IP address used for the anonymous access, the anonymous user, the IP address associated with that container or that pod, the fact that EKS admin was granting anonymous access, and that there was an attempt to get persistent access inside my EKS cluster. So these finding groups can be a really benefit as far as figuring out what do I need to investigate or what's actually happening inside my environments or within my Kubernetes cluster, and may actually help you better establish where do I need to go next when it comes to an investigation. Looking at things in a bigger perspective, this has got 3 GuardDuty findings versus 1 that may actually even make more priority as far as where do I need to start my investigation. It may help you figure out what you need to do rather than starting from a single finding or searching across a single resource. Let's go back to GuardDuty for just a couple minutes and talk about malware protection. So the malware protection feature was launched in GuardDuty July of this year at the Reinforce conference. It's just another feature of GuardDuty, and because it's GuardDuty, the first thing that stands out here is it's a fully managed feature. You are just responsible for accepting the service link role for this feature and turning it on. GuardDuty takes care of all the management and orchestration of this malware protection as part of the service. So what is it focusing on? It's focusing on right now on scanning AWS, Amazon EC2 instances. And it's going to be looking at instances that are related to a GuardDuty finding. So there are 29 different GuardDuty EC2 finding types that will trigger a malware scan of your EC2 instances. We're focusing not only on EC2, but everything that's going on EC2 from a container perspective. So this service is container aware. So whether you're running your own Docker containers and you're self-managing them, you're running Amazon EKS or ECS on EC2, this service can identify malware that is related to your containers and report back that information to you. And I'll show you an example of that in a few minutes. When malware is detected, this is going to show and help you identify it as a brand new finding in GuardDuty. It will be very clear that you have an additional finding around malicious files found on your EC2 instance. And we do this detection through a combination of our own threat intelligence, machine learning algorithms, and third-party engines that we incorporate into the service. And one of the biggest things about this, it's a managed feature and it's agentless. You do not have to install or configure or bootstrap any security configuration or any software in order to be able to make this happen or to take advantage of it. So let me walk you through how this actually works so you have a better sense of what this managed service is doing for you. The first thing I want to highlight, I mentioned earlier that you have to accept a service link role in order to be able to use the GuardDuty feature. That role is giving GuardDuty extra permissions to be able to manage and orchestrate some extra details within your account so that it can successfully scan and identify malware. And one of the key things here is around KMS keys. So if you are using KMS to encrypt your EBS volumes attached to your EC2 instances, that service link role is giving the GuardDuty service read permissions to be able to use those keys so they can then re-encrypt and view that data, or decrypt and view that data when it is doing a malware scan. So let's walk through a scenario where you have launched an EC2 instance. You've got a couple of EBS volumes that are encrypted with KMS, customer managed key. GuardDuty generates a finding around that EC2 instance, and that finding is one of the 29 finding types that would trigger a malware scan. First thing that GuardDuty is going to do is it's going to call the APIs to create a snapshot of each of the EBS volumes, and then it's going to share that snapshot with the GuardDuty service team account. We're then going to, in the GuardDuty service account, launch compute and create new EBS volumes and attach those to the compute, and those volumes are going to be based on those EBS snapshots that were shared with the GuardDuty service team account. We'll use the KMS key that's been shared with the account to be able to decrypt and be able to read that data. If any malware is identified, we will then report that back as a new finding in GuardDuty. We'll then delete those snapshots from your account, and then we'll retire or terminate the compute infrastructure used to be able to do that scanning. So what do you get? After all that's happened, what do you get out of that? So these are examples of findings. On the left is an EC2 related finding focusing on an instance that we observed Bitcoin mining occurring. And then the right-hand side is a malware finding, malicious file finding type. And you can see at the bottom, we're highlighting the threats detected. We'll actually highlight what was the malware that we found and where is it located on that particular EC2 instance. And we'll help you correlate that. You can see on the left and the right, it's the same EC2 instance. And so you have a stronger sense of what might be causing that particular EC2 related finding, because you're also seeing malware related to that same EC2 instance. We'll also help you if you want to understand specifically which GuardDuty finding triggered that malware event. Maybe you have multiple findings coming for the same instance. If you look on the malware finding, you will see the triggering finding ID. And you'll be able to use that to match up to a specific GuardDuty finding so you know which one of those triggered that malware scan, and be able to, once again, have more information that might give you more data on why a particular finding is occurring. And then we talked about this feature being container aware. So whether you're running self-managed, ECS, or EKS on EC2, we will report back the details about those containers as part of the finding type. So this is an example of an ECS cluster where we're reporting back the name of the cluster, the task in the cluster that this is associated with, and the actual container that this malware was identified on, so that you have very specific information from for an investigation or remediation related to this particular malware that's been identified in your containers. Okay, let's move on to Amazon Inspector and what Amazon Inspector can give you when it comes to containers and being able to identify vulnerabilities in your container images. So Inspector, we relaunched this service at reInvent last year. It is a vulnerability management service focused on doing continuous assessments of your EC2 instances and your container images that are stored in Amazon ECR, the Elastic Container Registry. We produce findings for these vulnerabilities in the Inspector console. You can consume them there directly from the console. If you're using Amazon Security Hub, we will push a copy of those findings to Security Hub. You can consume the events through EventBridge. We have lots of third-party partners that are integrated with Inspector to consume those and help you with your vulnerability management through those partners. And for containers, you can also go see the findings in Amazon ECR. If you have developers, engineers who are pushing container images and need to see what those vulnerability findings are, you don't want to give them access necessarily to the Inspector service, because that's got a lot more about other vulnerabilities that are present in the organization. They could just go to the Inspector, the Amazon ECR console, or call the ECR APIs and actually get the findings for their containers that they care about. So when it comes to the Inspector scans for containers, what we're doing is that every time an image is pushed to Amazon ECR, Inspector will actually get a copy, pull down a copy of that particular container image. We'll extract each of the layers from that container image so we can look at them individually and help identify vulnerabilities individually. We're going to first look at the actual operating system that's associated with that container and look at the packages that are installed through the package manager of that OS. But then we're going to go a lot further. We're actually going to look through the entire file system of that container to identify other places where you might have dependencies or libraries that are vulnerable. Inspector has support for 10 different programming languages so that we can look at those additional files and understand where you might have additional vulnerabilities that are present on that container image. We're then going to take everything that we extracted there and we're going to compare it against our vulnerability database to determine if you have any vulnerabilities present on that particular container image. So when you're using Inspector for container scanning, there's a couple different ways you can configure it. The first one you can configure it is for scan on push. Every time you push a new container image to ECR, inspector will grab it and do those scanning steps that I just talked about. In ECR, you can actually add filters as far as which repositories you would actually like to have scanned on push. You can also enable continuous scanning and implement filters on which repositories that applies to. And that continuous scanning means is that every time, after inspector has scanned it initially, every time the vulnerability database for inspector is updated, it will rescan those container images to see if there are any new vulnerabilities present on that particular image. Now, the way you can configure that continuous scanning is you can set a finite time frame, 180 days or 30 days. We have some customers who are regularly deploying new container images and they don't want the older ones looked at. Or you can set it for lifetime. So as long as that container image is there in ECR, we will continue to rescan it for new vulnerabilities. Now, some things to keep in mind: if you've set a finite time frame, the 180 or 30 days, when that time frame expires, we'll set the status for that particular image to inactive, and we'll set the reason code to expired, so you know exactly why we are no longer scanning that particular container image. We'll also flip the findings status for all the findings for that image to closed, and after 30 days, we'll delete the closed findings from inspector. Now, when you're actually in the inspector console, right away from the dashboard, we're going to give you a couple of key pieces of information to help you identify where you should be spending your time. We're going to give you the list of the most critical vulnerabilities identified, both for repositories in ECR, as well as individual container images. So this is intended to help you understand, where might I start? Where am I going to have the most impact when it comes to addressing my container vulnerabilities? But you can also go in and look at an individual container within Inspector to understand its vulnerabilities more. So we're going to give you details about that container, summary of the various vulnerabilities identified, and you can filter through or look at every single one of those vulnerabilities and the details related to them. You could also choose the By Layer tab, where we'll actually break down each layer of the container image and tell you which vulnerabilities exist in each one of the layers. And this can be important if you're trying to figure out, where am I going to fix my Docker build? Which parts of that do I need to actually update in order to be able to remediate those vulnerabilities? Now, sticking with the remediation, one of the recent additions we've had to inspectors, we're providing you more remediation guidance when we're telling you that you have vulnerable packages as part of your container images. We'll now tell you what are the affected packages. We'll tell you what's the affected version that we identified and what version is it fixed in. And we'll also give you remediation steps, steps you would run to actually upgrade that package so that you are now running on a non-vulnerable version. This is really helpful if you are looking to assign a ticket to a particular team. You might be able to include this information in that ticket so they clearly know where they're going to go to be able to remediate that. Or if you're building some sort of automation to be able to automatically address those vulnerabilities, you can use this information to help orchestrate that remediation automatically. Now, when it comes to the consumption of inspector findings, there's a couple different ways you can go about that. The first one we've talked about already is through the console itself, where you can go and look at the summary or the details about specific container images. You can also use the inspector APIs to query that and get information about active vulnerabilities across all of your container images or a particular container image. And the other ways that I really like, and I encourage customers to take a look at, are first of all, the event-based approach. Every finding that inspector generates, it will send a copy of that to Amazon EventBridge, which is our message bus service. You can then author rules in EventBridge with patterns to match all inspector findings or a certain severity level or certain types of vulnerabilities. And then when a pattern is matched, you can actually route that onto a specific target. And that can be 20 plus AWS services, as well as a third-party API endpoint, which allows you to be able to integrate that into your operational processes or to orchestrate a back-end response that you might be taking for that particular vulnerability. The other thing I'd like you to consider, and I point customers at, is the generation of an actual findings report. There are customers who want a point-in-time report of what are my current active vulnerabilities. Within Inspector, you can generate a findings report either through clicking a button in the console or making an API call. That findings report will be produced as either a CSV or a JSON file written out to an S3 bucket of your choice. You can then take that in as your current report of active vulnerabilities in your environment. Now, when it comes to remediation, we've talked about ultimately you need to go in and update, patch the software that's part of your particular Docker configuration and rebuild and redeploy that particular container image. Now, if you delete the container image from ECR as part of that remediation, Inspector will immediately close those findings so that you're not looking at them as still being active because that container image no longer exists. And then when you publish an updated image, Inspector will rescan that container image that you've updated. Now, one of the things our customers do, as I talked about earlier, is they have pipelines to be able to build and deploy container images. And with Inspector, one of the things you can actually do is integrate that as part of that pipeline. So in this example here, I have users pushing into a code commit repository. It's triggering a build in code pipeline. It's pushing that to Amazon ECR. It has a stage where it actually waits for approval. Inspector is going to scan that container image out of ECR. It's going to receive a scan complete message into Amazon EventBridge. In this case, I have it calling a Lambda function that's actually evaluating that scan complete message against thresholds that are defined as part of that function. So it's looking for critical, high, medium, and low thresholds to confirm is it in or out of bounds. We'll make an approve or reject decision based on those thresholds and then send that response back to the pipeline. If it's approved, that container image will actually be deployed into the next phase of the pipeline. Or if it's rejected, that pipeline will complete with a rejection status. So how do you do all that? So we now have a blog out that will walk you through in detail what were all those steps that were just there in that architecture diagram, give you a CloudFormation template to be able to deploy that solution in your own environment, as well as the code that goes with the Lambda functions to be able to actually do that investigation of your container images and make those decisions. So you can use this as a starting point to understand what is the interaction or what is the data that Inspector produces, and how might you incorporate that into your own pipelines to more automate being able to make the right security checks before your container images are actually deployed into your environments. Okay, with that, I'm going to invite Mrinal up, and he's going to talk more about HBO Max and what they're doing from a container perspective.
Thank you, Scott. I'm Mrinal Shah. I'm the head of container security for Warner Brothers Discovery HBO Max. My team is in charge of securing the containers and the clusters across the whole Warner Brothers Discovery portfolio, including HBO Max. For those who are not familiar with HBO Max, we're one-of-a-kind streaming service, delivering unique stories, complex characters, and immersive new world. We're home to some of the world's most loved content. We have an amazing sizzle for all of you here, so please enjoy.
Our worth is not given. It must be made.
You have no idea what loss is.
It's very intoxicating to bend the rules, color outside the lines.
Would you be interested in having an affair?
Oh, wow! Surprise! This is gonna be one of the best nights of my life!
What are we doing?
Changing the world.
That's right.
We're pushing forward!
I'm always chasing the music.
I have the drive, I have the passion.
All of this awesome content runs on massive AWS infrastructure. We have hundreds of clusters, which is a mix of native Kubernetes clusters and EKS clusters, running hundreds of microservices that scale up to tens of thousands of containers during prime time. We receive more than 1 billion requests per day, and we generate petabytes of logs per year. It's truly a massive scale. Some of the common container risks and threats faced by all containerized workloads are vulnerable application code. Application running in containerized environment may have direct or indirect vulnerabilities through open source projects or older versions of software libraries. We could have poorly configured containers and pods, which are misconfigured to run as root or allow privilege escalations within your containerized workloads. Insecure networking, where you have services allowed to speak with all other services without any authentication or authorization. This could cause one point of failure in case one of the services is broken into. And vulnerable underlying hosts, unpatched vulnerable hosts are always the biggest risk. Additionally, the risk of overprivileged services and users on the cluster, and secrets that could be exposed if they're stored within the containers or in plain text to the volumes attached to the pods. To monitor and mitigate these threats, the traditional threat detection model includes taking all the cloud plane logs and EKS control plane logs and the service logs and sending them to a central SIEM where security engineers build and run complex threat hunting queries, and they scan across massive amount of data to be able to detect if there's any anomalies happening within our environment. Additionally, every so often, you'll have service operators reach out to the engineers if they suspect there's anomalies within their services. There's challenges with this type of threat detection. The first challenge is it's not always easy to detect anomalous or malicious pattern. There could be several data points that make it hard to distinguish a real traffic from malicious traffic, especially with massive data sets that these engineers are scanning. Security engineers have to build complex queries on massive disjointed data sets and be able to see if there's any anomalies. To run all of this infrastructure is complex. And you need complex infrastructure to be able to support constant threat detection, especially when you're a multi-cluster environment. And real-time alerts are not always achievable. Security engineers are reactively searching for anomalies instead of proactively detecting them and fixing them. Keeping these drawbacks in mind, we fully embraced GuardDuty to protect our EKS clusters. GuardDuty seamlessly integrates with our environments, and it auto-ingests VPC flow logs, Amazon EKS audit logs, and DNS logs, and runs machine learning on top of these logs to be able to detect any anomaly and proactively send us alerts if something is detected. Additionally, GuardDuty helps us scale across the board because there's no additional integration needed inside the cluster. Once an anomaly is detected, we pivot onto AWS Amazon Detective. Amazon Detective, just like Amazon GuardDuty, collects and aggregates logs across different variety of data sources for us and provides us with a set of linked data to allow us to do faster and more efficient investigations. We're able to, once an anomaly is detected, we're able to pivot at cluster, container, and pod level to be able to quickly detect the root cause and quickly remediate them. But we don't always want to be in a position of reactively fixing issues. We want to proactively prevent and reduce risks within our environment. We're using GuardDuty to help us get there. Security engineers would commit their hardening scripts in a GitHub location. From where the pipeline picks up those hardening scripts and uses a combination of Packer and Ansible to bootstrap very secure hosts. These hosts are then scanned by inspector, and we extract the AMI, and we publish it to a central AWS location, from where it's made for those AMIs are made available for consumption by to developers using ISE code, ISE of their choice, such as Terraform. We also use inspector for helping us fix the images. So the first step of fixing images is being able to detect where the problems lie. We use inspector to detect all the vulnerable images within our environment. And once we detect those images, we go and identify which layer is introducing the vulnerabilities within that image. Once we have the full picture of which are the vulnerable images and where which layer is introducing that vulnerability, we take remediation steps such as swapping to a more secure base image, or upgrading the packages, or removing the build time packages that are not needed for the runtime environment. And once those images are fixed and pushed to a registry, such as ECR, we're able to do a continuous verification that there's no additional vulnerability present in that image. Additionally, we also use multi-stage Dockerfile on top of inspector to help provide clean container images to our developers. And the way it works is, this is the traditional single-stage Docker build. If you look at the Docker file, you can see that it's picking up an open source base image from Docker Hub. And then it goes about bootstrapping the application by adding the additional packages needed and and building binaries for the application to run. Once we run a scan on an image such as this, we'll find out that there's tons of vulnerabilities that were pushed into this container through the base image. So for this specific container, we would at least find 431 vulnerabilities that need to be fixed. So the team uses distroless secure base images, which is an open source project by Google, for providing a very slim base image which has no packages besides the packages that you only need for building your application. And all the build time packages that are not needed for the runtime are removed from the application. And the way it works is we allow you to use any image that you need for building your application, and then we take the build artifact and we push them onto the secure base image, which has nothing but just enough packages for your software to run. It doesn't even have enough permissions to be able to execute within that base image or be able to download additional packages. So there's no package managers or no bash or shell within these images. And when we scan such an image, you'll find out that most of the vulnerabilities or all of them are gone. Now that we once provide clean AMIs and clean base images to our developers, we want to be able to continuously scan our environments. We want to be able to scan our hosts, and we want to be able to scan our containers in case any vulnerability out in the wild, such as Log4Shell, comes into the picture. We want to be able to inventorize all of the packages and CVEs that are running within our environment. And we're using inspector effectively to be able to do that within a single AWS account. But we don't stop there. We're multi-AWS, we have multi-AWS footprint, and we're using AWS organization to funnel all the logs from GuardDuty, inspector, and detective in a one consolidated AWS account, which is open to the security engineers to be able to query any host and image to detect the vulnerabilities present in them. This gives us a holistic view of everything that's happening in our environment. With that said, thank you for sticking in such late. And yeah, we'll have a survey passed after this, so please fill out that survey to let us know how the presentation went for you. Thank you.